Hi, Thinkstrumentalists. Today I want to share with you a very basic introduction to AI and in as non-technical way as possible, share with you what I learned at MIT studying machine learning and artificial intelligence. So it's really a crash course in a way. So since their invention, computers have primarily been powerful calculators, machines that execute precise instructions given by programmers. However, we're now witnessing a technological shift of unprecedented scale. Computers are no longer just following instructions, they're learning, thinking, and even communicating in ways that resemble human cognition. And this new frontier is called generative AI. Now, you're probably already familiar with generative AI with tools like GPT, Gemini, Llama, DeepSeek and such. Now, essentially, intelligence is now available as a service. Think of it as a vast dynamic brain floating in the digital realm, accessible to anyone. And while it's not perfect, its capabilities are expanding at an exponential rate. And this shift is monumental, and it's poised to impact individuals, businesses, and entire world industries. And we see that in stock markets with graphics cards and stuff like that. So the more you understand it, whether as an individual, a team, or an organization, the better equipped you'll be to navigate and leverage this transformative technology. So, although I'm not going to go into huge technical detail on some of these following concepts that we had to learn at MIT, I really believe that they're worth sharing and mentioning to just give us a background on the level of complexity that one needs to master when working on the back end of these systems and understanding where the output is derived from and how we can better derive outputs as well. Because in essence, and you're going to see this, when we use the word AI, we may as well use the term mathy math because there is a lot of math and statistics behind it. So here's a quick look at what's under the hood. And apologies, again, in advance for the word salad, the awkward acronyms, the techno-babble. There are things like linear algebra concepts, vector spaces, eigenvectors, eigenvalues, matrix decompositions, principal component analysis, manifold learning. There's probability and statistics in there. So we look at things like probability distributions, Gaussian distributions, Bernoulli, binomial, Poisson, Bayes. We look at maximum likelihood estimation, maximum a posteriori estimation, expectation maximization, and really as a highlight, there's deeper than that. There's the statistical learning stuff and information theory, entropy, Kullback-Leibler divergence. There's cross entropy, loss, bias variance, trade-offs. There's stuff like optimization and gradient-based learning. There is stochastic neighbor embedding, gradient descent, Lagrange multipliers, and so on and so on. Okay, so enough of all of that. The point is, to grasp the power of generative AI, consider this metaphor. Imagine having Einstein in your basement. And more than that, imagine that your Einstein is a collective intelligence, encompassing the knowledge of every brilliant mind in history. You can consult him at any time, on any subject, and receive instant responses. So this Einstein can play multiple roles. He can be a poet, a doctor, a coach, a strategist, but he obviously has limitations. He can make mistakes. He can misinterpret questions. He can even hallucinate. He's a quirky buddy. The key to utilizing him effectively is how well you can communicate with him, a skill known as prompt engineering. And in the era of AI, prompt engineering is as essential as literacy itself. So most people vastly underestimate what this Einstein in the basement can do. And the way some people use him, it's akin to asking the real Einstein to proofread a high school essay, or hiring a Michelin star chef to just chop onions for you. The better you communicate and experiment and engage with it, the more you unlock AI's immense potential. It's not what AI brings to you, it's what you bring to AI. So what is AI and how does it work? So AI, or artificial intelligence, or math, is not new. It's been going since the Second World War. Traditional AI has powered everything from YouTube recommendations to credit card fraud detection, and it's done this for decades. Generative AI, however, is different. Instead of merely analyzing and categorizing existing information, it creates new content. That's the G in GPT. It stands for generative, pre-trained transformer, GPT. Large language models, known as LLMs, are an example of generative AI. They leverage a neural network, which is a complex web of parameters, hundreds of billions of them, connected similar to how neurons work in our brain. However, these networks process numbers, converting inputs into numerical representations, and then predicting the most likely next word, image, or action based on the training data itself. Now, to train these models, they are fed enormous amounts of text, images, and other data, and this allows them to recognize patterns and generate responses with increasing accuracy. They learn very much like a child through exposure and repetition, constantly adjusting their parameters to improve accuracy. So while GPT popularized generative AI, it is far from the only model available. AI models vary in speed, capability, and accessibility. Some are cloud-based, while others can be run locally. Some are open source, while others require subscriptions. So it comes in all sorts of shapes, sizes, and forms, and it runs finance systems, stock market predictions, that type of thing. So the capabilities of AI models extend beyond just text generation. So we have text-to-text models, and it converts input text into structured output text, and that's used for code generation. You have text-to-image models, and they create images from textual descriptions. You have image-to-image models, and they transform or enhance existing images. You have image-to-text models, and they describe images using AI vision. Take a photo and say, what am I looking at? You've got your speech-to-text models, so they can transcribe audio into written content. Then you've got text-to-audio models, and they generate sounds and music from the texts, prompts themselves. There's now text-to-video models, so you can create video content based on descriptions. So as AI evolves, multimodal models are emerging, integrating text, images, and audio into a seamless user experience. This AI revolution is faster than any other revolution that has come before. Throughout history, technological revolutions, whether the printing press to the steam engine to the agricultural to the industrial age, have reshaped society. However, AI is different. It spreads globally in an instant, while previous revolutions took decades to become widespread. AI's impact is immediate and ever expanding. And this presents a challenge. Adapting to AI's rapid advancements. It feels like you're drinking from a fire hose with everything that's going on. And people and companies often fall into two extremes, either denying AI's relevance or fearing it will replace them. And the reality is somewhere in between. AI is a powerful tool that enhances human capabilities. Those who learn to use it effectively will gain a significant edge and have gained a significant edge. So the future of work is a human-AI collaborative scenario. And a common question that arises is, will AI replace humans? And the answer is complex. Some jobs will disappear, but most roles will transform. And the key lies in getting this collaboration right. So AI is an excellent assistant, but it does require human oversight. A lawyer using AI for legal research still needs to interpret case law. A doctor using AI for diagnosis must apply clinical judgment. A teacher using AI for lesson planning must still engage with the students. It's a tool and it's a force multiplier. So instead of viewing AI as a competitor, think of it as a super intelligent yet slightly unpredictable colleague. Brilliant at some tasks, but requiring guidance. The most successful professionals will be those that master this collaboration. So there'll probably be a new term, AIQ. Like EQ, we'll have an AI quotient that develops as an intelligence set. So to unlock AI's full potential, you need prompt engineering. It's the art of structuring questions and instructions to get the best responses. So, think of these examples. If you give a vague prompt like, help me plan a workshop, it's going to yield very generic advice. It's going to meet you at the level of your question. You can have a more contextual prompt. Help me plan a leadership workshop for mid-level managers. Now it's going to zero in and funnel down to more relevant answers. And then you also have iterative prompting. What do you need to know to help me plan a workshop? So you actually encourage the AI to ask clarifying questions. So there is a complete science behind the way you prompt. It's like programming with words. And the better you are at it, the better your results will be. So here's a quick rundown on some of the major ways you can construct your prompts. So you have what's known as reasoning-based techniques. You have chain of thought prompting, a COT, and it breaks the problem into intermediate reasoning steps to improve logical accuracy. You have tree of thoughts, TOT prompting, and this expands reasoning into a tree structure, exploring multiple solution paths. You have zero-shot chain of thought, which encourages reasoning without prior examples by adding, let's think step by step to the prompt. Then you also have least to most prompting. And this solves complex problems by breaking them into simpler sub-problems first. We have something known as self-consistency in COT. And what this does is it generates multiple COT, a chain of thought responses, and selects the most common and most coherent answer. We also have program-aided language models, PAL. And this uses external tools like Python or symbolic logic and other codes-based structures. You then have structural prompting. And structural prompting is you've got few-shot prompting. So this provides examples to guide model responses in the desired format. You've got zero-shot prompting, and it directly asks the model to generate an answer without examples. You've got one-shot prompting, and that just gives you one example to set the format in some kind of logic. You've got instruction-based prompting, and this clearly states what the model should do. Example, explain in simple terms X, Y, Z. You've got multi-turn prompting, and here again you break a complex task into multiple interactive steps. You have hierarchical prompting. So this structures prompts with multiple layers. Example, summary first, and then the details, and then the calculations, and then the summations. You've got self-refinement prompting. This is where the model evaluates and improves its own output iteratively. You've got error reduction and robustness when you're trying to build that in. So you'll have self-critique prompting. So you ask the model to evaluate its response and suggest improvements to itself. You've got prompt chaining, using multiple connected prompts to refine output steps, and it does it step by step. Then you've got what's called react, which is reasoning plus acting. So it combines reasoning with action-oriented steps, and it's often used in agents. And we'll get to these agents a little bit later. Then you've got consistently based prompting. So you generate multiple responses and select the most consistent one through all of them. Adversarial prompting. And this challenges the model with tricky or edge case scenarios to improve its robustness. You have prompt tuning and soft prompts. And this fine tunes the prompts using embeddings rather than raw text. You have multi-agent interactive techniques. And this is a cool one. It's one that I enjoy. It's multi-persona prompting, using different character perspectives to improve the output quality. So you could ask a question and say, we're a room full of environmentalists, business, finance, and so on. You can have debate prompting, creating two conflicting responses, and then have the model refine the quality of the argument. Role-based prompting assigns the model a very specific persona to guide its response. You are a professor, you are so and such. You have recursive critique refinement. This model revisits previous responses and iterates again. Then you also, one of the big things is something called RAG, Retrieval Augmented Generation. And that's really about how the knowledge is structured first to be retrieved, and it uses external databases or memory to provide richer responses. You have knowledge injection prompting, and this is where you supply additional domain-specific knowledge before asking the question. You have memory augmented prompting. This stores previous interactions to improve continuity and long conversations. Also, the context window optimization, and optimizes what information fits within the model's token limit for better responses. Because remember, everything runs in these tokens. It's a little equation that you're running. You also have some pretty advanced techniques. That's all pretty basic. You've got auto prompting, which is automated prompt generation. So you use AI to generate and refine prompts dynamically. You've got meta prompting. The model is asked to generate its own prompt based on users' intent. There's contrastive prompting. So this actually compares responses from different prompts to refine accuracy. There are prompt ensembles, and this takes multiple prompts or models to improve reliability and depth. In a nutshell, the better your prompts, the more precise and valuable AI's responses will be. Practicing this skill it's not only improving your AI interactions, it's actually going to improve your communication abilities, your critical reasoning faculties, and all of that as well. Now, we're in the next frontier. It's already happened, and this is what we call autonomous agents. So beyond chatbots, the next evolution in AI involves these agents. And guys, this one is big and is happening more and more by the day. AI systems that can take independent action instead of waiting for prompts. They can complete tasks proactively, and so they can automate entire workflows. They can conduct research and synthesize reports, manage online customer support. And that area is, you're almost going to have two streams, the human stream and the AI agent stream in HR. Anyway, key takeaways. Generative AI is a powerful tool. It can revolutionize personal and professional productivity. The biggest limitations are not AI itself, but in our ability to imagine and communicate effectively with it. Prompt engineering is a crucial skill. You need this. It's to augment what you're currently doing, and experimenting and refining your AI interactions is just the best way to improve. AI is an enhancer, not a replacement. Human expertise combined with AI creates the best outcomes. Autonomous agents are emerging. Understanding their potential and limitations is essential. It's essential. It's vital. I can't emphasize this enough for staying ahead of the AI revolution. Simply, the future belongs to those who embrace AI, leverage it creatively, and adapt to its evolving capabilities. By understanding and mastering generative AI, you can position yourself and your organization for success in this new era. Remember, calculators didn't make math easier, they made it harder. Thanks for watching.